Hello from Hong Kong. First of all, happy anniversary. I believe this is the 20th anniversary of when the term VDC was born. So happy anniversary. Today, we are very glad to be here to share about what are the progress, what are the opportunities to scale up VDC globally. I'm Calvin Cam, and joining us in person, it's Min Sung and also Jim Bedrick. Min and I overlapped at CIFE back in 2010 while we were looking at how to work with VDC for owner-driven innovation. And with Jim, I remember that more than 20 years ago, I was working with a group of CIFE students trying to model the California Academy of Sciences projects, coming up with our own BIM, with our own kind of like a VTE model, with also kind of like a 4D model, and use the old iRoom in which we need to work with the computer science departments to animate the 4D sequence of the museum within 2 or 3 days time of modeling, and be able to report and show to web core leadership why there would be value in looking at VDC for concrete and steelwork. And then afterwards, Jim actually was one of the first major projects to apply that. So if our slides are up, so over the last 20 years, our team has been working on a number of owner-driven VDC applications, and sorry, can I also see the slides to make sure that it's also on? Okay. Oh, is the local audience seeing the slides, I guess? Oh, there you go. Thank you. Oops, sorry. Okay, there we go. Okay, so over the past 20 years, our team has been working on how to scale up VDC globally. Over 20 years, 20 countries. In many cases, it's about how to work with owners and government agencies and able to scale up the supply chain, able to not only work on pilots after pilots, also looking at how to globalize it, how to manage it, how to operationalize it. I think very often we may celebrate success in terms of what we do with VDC, but I think the real test is whether a certain team of leaders, the CEO, the VDC champion, if they retire, or if you get the third generation coming in, whether the VDC culture, the VDC kind of like strategy is still in place. I think that's a very good test of the doability of VDC program. And then in terms of the VDC framework, I think if we there you go. Okay. So for example, over 20 years ago, we were working with one of the first global use of IFC in Finland. And at that time, the client objective was about how to leverage VDC to make sure that the professor in Aalto University would be able to better interact, better teach, better work in the auditorium projects. But then we were able to report 50% reduction of construction documents, and also the pluses and the deltas of using OpenBIM at that time. Speak about sustainability, life cycle management, life cycle assessment certainly were important kind of like VDC approach that we took. Then from Finland government, Senaatti to the GS equivalents. For the last 20 years, we have been working closely with GSA. And again, the client objective is about maximizing the American taxpayer value for the American taxpayers. So how we could also preserve historic landmark was very important for the GSA, Public Building Service. So back in 2004, we were looking at how to bring 3D imaging, 3D laser scanning to public buildings. And even though we spent over $100,000 for a partial scan of 26 Federal Plaza back in the winter days of 2004, we were able to work with the construction managers to work in a mini eye session and able to report that there would be an 800% return on investment because of the earlier existing conditions and error and omissions that we were able to preemptively avoid. So it's very important to understand those client objectives and able to bring VDC approach accordingly. One thing that should make this community proud is that when my team stepped in to meet with the project director of the Kai-Tak Sports Park project in Hong Kong, he did not take any of our courses, but he came into the room with the IPD book by Martin, by Dean, by Atul, by Howard, and telling us how not only did he follow it, read it, he's actually embracing it. And actually, the book was with him in the trailer. So that was very, very impressive. But for this kind of projects, which is 4 billion US dollar, working with hundreds of consultants from Australia, US, and across Asia, that there was still quite a lot of challenges in terms of production. And so what our team ended up was to really help them to understand that the owner come up with too lofty, too ambitious the requirements of the level of development of the production schedule. And in the end, we were able to see that they were able to gain some VDC benefits, which you can read right here through automation, through better production planning, and of course, good use of BIM. Next slide. And what we find was that it was very, very important for us to really have an A session in that case with the government agencies on this 30-year design, build, and operate job, and able to articulate kind of like what would be the client objective, what would be the project objective, how we can make it also understandable, not just with what the original consultant wrote a few years ago about the lofty ambition of the project, but how to really make it to be a smarter stadium project. I still remember that working with Jim back then with the California Academy of Sciences project, there was not much definition about LOD, about reliance of BIM. So Jim, reflecting on the last 20 years and looking forward, what have we learned?
Thanks, Calvin. So this is the California Academy of Sciences. This is the one that Calvin mentioned. And this is about 2003 when BIM pretty much became mainstream. And the first people to adopt it really were, at least in the US, were the trade contractors, because they saw that this is really a tremendous way of coordinating our work. Works much better than the old superplot method. It worked well enough that I was working with Webcor, the general contractor on this project at the time, and shortly after this project, a couple of our trade contractors came to us and said, if you require everybody, all the trades, to produce 3D models like this, we'll give you a lower bid. So it really, money was talking already. Obviously, we've moved on. We're doing a whole lot more than clash detection now. There's various and sundry simulations we're doing, costing, scheduling, operations, and so on. But can we really rely on these models? If I'm a builder and I get a model from the architect, can I build from it? And this is a BIM problem. It's not, we didn't have this problem with drawings. A couple of the major problems we ran into was, first of all, we lost the visual cues on the state of development. In drawings, if the thing looked like the thing on the left, we knew everything was approximate. The problem is with models that if we're at the napkin stage or 100% CDs, it always looks like the thing on the right, all right? I can measure the location of that door, but if we're at the napkin sketch stage, that location is probably going to change. They often carry unintended information, right? I probably grabbed that door out of the library just as a placeholder, right? And it's going to change. So the response to this has been when somebody hands a model over to somebody else, they put this disclaimer on it. It says it's for reference only, you can't rely on it. And really the theory behind that disclaimer is some of the information is not reliable, so don't rely on any of it. Right? When we got a hold of this in the AIA Documents Committee, we developed a specified use approach. Basically said, yeah, some of the information is not reliable, so only rely on what I say you can for the purposes I say you can and to the degree of precision I say you can. We need a language to articulate this, right? Well, enter level of development, level of detail. Started back in 2003, kind of the first example we knew of it was when we were working with Graphisoft. Well, it exploded because somebody once said that we must really love standards because we make so many of them. But it got really interesting about here. And that's when the AIA Documents Committee developed this idea of level of development. And the difference then is level of detail is really the quantity of detail. How much is there? But this thing on the right has a high level of detail. It looks like specific steel shapes. Probably is, because I probably grabbed them from a library, didn't build them myself. I can measure the location precisely, but have they been engineered, and are they in the final locations? I can't tell by looking at that model. So, things progress through the design process at various rates. The structures usually leads everything. Things like interior casework bring up the tail end. But they all tend to hit common milestones. You start with a concept, you put in some generic placeholders, you swap those out for specific assemblies, and some of them you take to shop drawing level details. Well, so we labeled these milestones LOD 100 through 400, and now we have this schema that represents the reliability of the detail, okay? So level of development then answers these last two questions. At LOD 200, the answer to both questions is no. It's not, they haven't been engineered, they're not in the final locations, so I can't rely on it for that. At 300, the answer to both is yes, okay? So the evolution of these definitions was, first of all, Graphisoft came up with this level of detail scheme, and it went on to, when the AIA got a hold of it and morphed it into level of development, a couple of updates, and then the BIM Forum, a interdisciplinary group in the US, got a hold of it and made this LOD specification, which we'll detail in a minute. But one of the major developments was that in 2015, the BIM Forum took this, the BIM Forum took this and interpreted these definitions. The big one was that we said, okay, since 300 is specific details, we can measure it. Caused a lot of heartburn among architects at first, but those that really saw what was going on bought into it. Last summer, we got together a wide group of industry organizations, redid or updated the LOD definitions, and basically baked these BIM Forum interpretations into them, including the measurability of 300. So, all right, this is fine. We've got these definitions, but still, what I think of as a 200 door, an LOD 200 door, might be different than what you think, okay? So the BIM Forum got together and developed this specification, basically as a dictionary. Okay, so now, this document, it basically interprets various and sundry building systems at the different LODs. So now, if I want certain information on a door, I can look in here and say, okay, that's LOD 200. I can tell somebody else that I want LOD 200 doors. They can look in here and know exactly what they need to give me. A couple of years ago, this started to go global. NBS from the UK came to us. They said, we think you've got the best LOD framework and specification. We have a breakdown system that we are going international with, Uniclass. So we want to map your specification to Uniclass, which we did. In 2020, that mapping came out. Now, the spec and the definitions and the whole framework of LOD has been a tremendous support for collaboration. Well, what's next? Okay, as far as reliance on models goes. Well, how about models as contracts? If you look at the evolution of contracts contract documents. A while back, we were doing drawings, separate drawings. You move a window on the plan, you got to go through half a dozen drawings and move it there. We progressed to taking drawings as views of the model. Okay? Now I move the model, the window in the plan, it moves in all those other drawings. The thing is, if you look at that small apartment building, 152 of those sheets came directly from the model. Why are we composing all these sheets? When we took this on in the BIM, or in the AIA Contract Documents Committee, we started in 2013. About half the group was said, okay, well, we can look into this. The other half said, no, never. Over my dead body. We're never going to make that model a contract. One of the people who was most dug in against the idea wound up being the lead of the document that supported it, because he took a look at it and he said, you know, this is going to save me a lot of time. I don't have to compose these sheets anymore. And the thing is, it's not the next step, it's happening now. Especially in the horizontal industry, it's happening so much that they have their own acronym for it. MALD, Model is a Legal Document. 4 states are planning for it, 4 are conducting their first pilot, and 6 have designed and constructed a project using models as contracts. Okay? It's also now gone into the vertical sector, and now last summer, AIA came out with the latest BIM exhibit, and it specifically supports the idea of a model as a contract.
Okay, now scaling up BIM to GIS. So one of the work that we're doing at SBI is integrating BIM and GIS, but not using native formats like Revit or Tekla, but we are using open formats like IFC and CityGML. And the main reason is it's usually the government agencies that need integration with BIM and GIS, and they tend to have, in the future, probably in a Hong Kong case, 300,000 models, because they do have a lot of facilities in the city. And it should be speaking in the same language. If some models are built with a Tekla language and some models are built with a Revit language, it will be very difficult to do anything and query information. So you need a consistent format. That's why we are using OpenBIM and open standards for the GIS as well. And on top of that OpenBIM and OpenGIS platform, what we are doing to improve the quality of the BIM is also using Building Smart's new machine-readable specification, BIM specification called IDS, Information Delivery Specification. And the intention of this is you can create a model checker within a Revit, for instance, but you cannot really export that rule set to a different software like ArchiCAD and use that again. So intention is to make this rule set interoperable between different BIM authoring tools, so you can use it for multiple purposes and by multiple stakeholders. And so this is the prototype platform that you're seeing on the left side. It's done with our Dutch partners. And this is using open standards, pretty much 100%. We have IFC in here. We have CityGML for the GIS part. We have for the data streaming over the internet, we do use a GLTF, Cesium, and 3D tiles, which are also open standards. And on the right side, that's the IDS checker, if you will. It's like a model checker that's using the machine-readable format IDS XML. And here, the information requirement for the government agency is on a high level, like whether you have the georeferencing information embedded in the BIM or not, and whether the model is simplified or not. Because when you have 100,000 of models, 300,000 of models in a platform, it should be very light and maneuverable. So simplification is another example of requirement for this project. So some metrics in this project, we used 7 open standards and developed the 10 IDS file formats for different checking purposes. and also tested that IDS checker, or basically the model checker, was 149 IFC models. And of those 149 IFC models, 102 were infrastructure project models. And when we run this IDS checker, on average, it took only about 12 seconds, so it was very usable. And just moving forward, what we plan to do is a lot of people tend to think that IFC is an archiving format, but we are also trying to leverage IFC-based APIs. So some of the examples that you see here are all software that were developed using IFC-based APIs. The 4D simulation case on the left side, that was inspired by a research work that was done at CIFE more than 10 years ago. And you do have other use cases like the advanced query, querying against the city model as a whole, and also flooding analysis, which integrates with another flooding analysis engine by using APIs, which is IFC-based API. Moving on to the production management side of the VDC framework now. So this is actually work that stemmed from CIFE Stanford. And the planning level that we are interested in is similar to what Lupo talked about when he talked about lean to field. So it's not about master scheduling, phase scheduling. It's more about the scheduling or last planning system for the site people like the foreman. And typically what we see in the industry today is this type of a physical board with sticky notes. And if you see those sticky notes, it will tell you what the foreman has to do on a certain day. It does have some information, but it does lack detailed, precise information in terms of resources like the quantities and whether the equipment is available or not. Also, the PPC is very, on a rough level calculation. They just count the number of sticky notes, and it's not really based on bin-based quantity type of metric. So this is the research prototype that was built at CIFE. We do have the LOD 400, BIM here. Of course, we are not, asking industry to go with LOD 400 for all of their projects. But if the projects do have LOD 400, they can leverage this information. So we're using LOD 400 and building a production unit boundary, imaginary boundary, to capsulate the work scope of the foreman for that day. By using that, we can also quickly generate daily work orders, which do have precise and accurate quantity information coming from BIM LOD 400. So during the study here at Stanford, we did test this out in North America, South America, went to Middle East, went to Europe, and did a lot of test cases. At SBI, we extended this, and we never implemented this in Asia. So we did test this in Hong Kong as well. It was a high-rise building project with the curtain wall trade that was the focus of this test run. And for the curtain wall trade, we implemented this for 6 months and generated 143 daily work orders. And on average, it took around a minute to generate a single daily work order. So this is the 4D simulation of the work done in Hong Kong. This is the high-rise building project, and each of the black cells that you see is a curtain wall unit. And at the bottom, you can see that you have the productivity and the productivity index, the metrics. And one thing that you can see is that variability of the productivity kind of reduced over time. Whether that's due to this platform or software, I don't think so, but this software or the platform does help you to visualize that variability over time as well. And in addition to tracking the work done at construction site, we also try to track supply chain, so tracking whether the prefabricated unit has been completed or produced at a factory or not, and whether it has been delivered to the site or not. So that part of the progress tracking has been also implemented to this case. Some room for improvement. So a lot of this and the success of this depends on the cooperation from the site. At this project, the site people and the foremen were not, fully cooperative. So one way to work around this is maybe build into the information requirement and say that subcontractor and foreman should be inputting this type of information on a daily basis. Because if it's not in the contract or information requirement or specifications, they tend to kind of overlook this type of work. And just moving forward, another room for improvement is we did manage to help foremen generate these daily work orders quickly, on average like a minute or so. But a lot of things that we have been hearing from the foremen is, can we automate the update of the progress? So we do have a lot of technologies that we can leverage today, like RFID and computer vision, so that it can automatically detect the objects or the elements that's installed at the site. So next task that we are planning to do is whether we can think about, whether we can integrate these types of industry technology that's kind of already out there. So that's the RFID and the computer vision part of it, and I would say this is not so much of a research question, more of a development question that we can look into, because we do see a lot of technologies already out there where we can adopt this for this purpose. So next, Kelvin, we have the ICE part of the VDC framework. Passing it back to you.
Next slide, please. Thank you. So in the early days, about 10, 15 years ago, there were a number of Walt Disney Imagineers who have come through the CIFE certificate program in VDC. And many of them later on then became the champions of how to apply ICE VDC in a number of global Disney projects. And SBI also want to take these two examples, the hotel projects and the castle project, that was just also reported by Disney Imagineering President Barbara Boser at the AIA conference just a week ago in San Francisco. So with the hotel projects, our team at SBI actually teamed up with Disney and actually designed the ICE session for 12 sessions. About 100 people would fly in from around the world to the same Disney ballroom and hold ICE session, in some cases for a week long. If we go through some of those, and so we would be kind of like really keeping an eye of like how engaged, how much they contribute, going back to some of the CIFE earlier framework of are they spending more time explaining stuff, or are they spending more time kind of like really contributing and collaborating and making good decisions? And also per decision, what did it take without the ICE session? About 15 days, $7,500 per issue, 58 hours per issue. But also then looking at what were the critical path, what were the commitment reliability, who had the worst commitment reliability. In some cases, it was the owner themselves. So let the metrics, let the public explicit metrics to tell the story. And so we all can actually also see the reality. Next slide. So, and of course, ultimately, the client objective is to really let the guests have happy moments in their facility, in this case, and fun. And then also part of the important stakeholders is to actually get the chef to come into the ICE session and understand what that means in terms of their future kitchen. So we also track how these ICE sessions trended over time. And then indeed, some of these were like quite a few years ago. So BIM actually only was at the main stage for about 21% in the maximum of the total kind of like week-long session. But we did also see a correlation of how effectiveness and satisfaction would be positively correlated with some of those increased use of BIM and VR-driven review process. And then moving on to the castle, that was built during COVID, and actually the Disney president, Imagineering president, made really quite a nice story at the AIA San Francisco. DPR, GSA, among others, were there too. So when we came into that 2-day ICE session, we were planning to only have only have like a page flip by the design manager who did not take the VDC course from Stanford. So teaming up with her, we totally changed kind of like to pre-design what was the agenda, how we could make it efficient. In the end, we were able to identify a major outcome that the Disney castle would have no fireworks during construction. When all the operators were thinking that there would still be fireworks and the show would go on. So that was a major aha moment that was generated from the I session that allowed us to preemptively solve that. So in the future, with AI, with ChatGPT, how we can make some of those I session to be more informed, to be able to make more informed decision and alternatives, certainly also something that we are looking at. So in the final segment, in terms of kind of like metrics, right? Basically, we have been working with Asia Pacific Economic Cooperation to look at how to measure that from 21 economies, all the way to working with Disney and looking at how to measure particular parts. Next slide. So one case is that we have been working with a 118-story, one of the 10 tallest buildings in the world, the ICC. So they are in operation for 10 years now. Then we are looking at how to leverage VDC and to really improve the leasing and the operation. So in these cases, it's about really empowering the clients to make the handover and the takeover process for the tenants to be 92% more efficient in terms of some of the co-checking and also a 75% efficiency gain with some of the handover process and also the onboarding process. So those were some of the ongoing kind of like lessons learned. And even though, yes, there was a BIM being built and so forth, then it's a lifelong journey to work with those tens and tens of operators. Working with APEC, that makes up of 21 countries, economies, 60% of the GDP. We work with them to look at reminding them that you need to look at status quo. I think like what Peter was saying, that we need to look at the metrics, the status quo, and then we also capture from 21 countries, what were the green metrics? How can we use VDC to empower some of those and how that led to smart city development in APEC. Some of the final slides reflecting back 10 years ago, 12 years ago, Martin may remember we were going to Disney Shanghai. Many of the design team, construction team were new to VDC. Within one project time, the Disney Castle in Shanghai won some global awards and they never looked back. Similarly, with Singapore, I think we have gone through 9 courses with Singapore leaders, government, private industry, and that is now becoming a policy in Singapore to work with VDC, to work with DFMA and beyond. And then more during COVID, over 200 professionals, including those responsible for 60% of the $330 billion construction volume in Hong Kong, have taken the VDC course, even during COVID, online, self-paced, and are coming up with the requirements that every 6 months, they need to submit the KPI to report on clients and project objectives. So the journey is still on. And so I think in closing, there's still so much we can learn from other manufacturing industry. If Airbus and Boeing can not only report on the number of parts, but can even tell us that 1 kilogram would equate to $1 million of life cycle cost, or by flying 2 minutes slower, we can save $13 million of fuel. What can we do more to leverage on these kind of like data analytics? We are still not anywhere close in terms of part type optimization or construction, kind of like don't just go fast. What if we go slow a little bit? How much more sustainable can it be? Do we have those informed decisions? So in the end, we are also working with Building Smart International to see if we can come up with a global platform to report on business values, sustainability, productivity, and other values. And actually this year, if anybody may be going for the BSI awards, some of those designs, some of those metrics are in place. So there's also another opportunity for CIFE, for Building Smart to team up together to look at that from education side and also from metric celebration and analytics side. So with that, I'll pass it back to Stanford.